right now. Yes, I see the live icon. Hello, can people hear us in the chat?
Hi, Mom.
Somebody let us know if you can hear us live in the chat.
Wow.
All right, we'll get this kicked off in just a second. Okay.
Awesome.
Oh, maybe there's a lag. Oh, they can't hear us, but they can see us. They can hear.
Yes, but
some people can hear, some people can see. Everybody's good. We can hear, we can see.
Okay.
Can you guys see us? They can't see us.
Okay, so
Let's try that view.
Okay, they cannot see us. They can only hear us.
I'm gonna just turn off my camera real quick.
Okay.
Wait, they can see us now. I just turned off my camera. Well, let me turn it back
That's
on.
what it was, Mike. You were putting them off.
No, I don't get it. My camera's off right now.
Okay. No, you can turn it back on. I think we are good.
Can you see me now? We're all good. Okay. Can you see Rodney?
Yeah. So there's like a 20-second lag. So they're just responding for 20 seconds ago, so they can see us now.
Just so we don't swear too much and they can cut the thing. So okay, we're all good now. Wonderful. So cool. All right, let's get this going. Let me share my screen here. We're gonna present.
Mm-hmm. Okay.
All right, Rodney. Are you seeing my presentation load?
Yep, we're good.
All right. Sounds good. Apologies for the rough intro there, but we are really excited to be here today. Welcome, everyone. I see some friendly faces in the audience. I see a lot of people I've meeting first time, so welcome, everyone. Rodney and I are excited to be here to discuss how to build Gatsby websites securely, Gatsby web applications securely. So Gatsby is known for being a super fast front end for the headless web. And it really got its start as a powerful static site generator. But today we're going to dive into some of the tools at your disposal in the Gatsby ecosystem that will allow you to not only secure your static sites, but build powerful, dynamic, and most importantly, secure web applications. So if you have a question during the presentation, ask them using the QA tab. Rodney and I will be checking that, not the chat, and we will be doing our best to address your questions during the presentation. But before we start, let's give a quick background about ourselves. And Rodney, you are first.
Sure. Okay, I don't know if people can see that well, but they'll let us know in the chat. So my name is Rodney Matambo, and Mike was the one who called me a JavaScript and React extraordinaire. I think I'm like decent, like upper class decent, but I've got a few things to say about it. So hopefully it'll be helpful today. So a little bit about myself. For much of my life, I was doing a lot of nonprofit work all over the world. So things like designing sites for underprivileged communities, directing schools, taught classes, led community impact projects. Along with that, I ended up also teaching in orphanages and different places and high schools, biology, chemistry, physics, blah, blah, blah. And a couple of years ago, I decided, you know what, let me dedicate more and more time to one of my passions, which is software engineering. So I ended up building out a JavaScript framework for that deployed static sites with serverless functions. And, you know, tested it with Gatsby and all that stuff. And so currently I work at Gatsby. largely improving our GitHub, GitLab, Bitbucket integrations with Gatsby Cloud, authenticating our Gatsby Cloud using OAuth 2 apps and JWT. So those are some of the things we're going to be talking about today. But that's a little bit about myself.
And Rodney, and speaking of a lot of the stuff you work on here, you led the project, right, for the on-premises GitHub Enterprise. That's what I meant to say.
Yeah.
Okay, so you're at GatsbyConf, right?
Yeah. So one of the things we're actually releasing at GatsbyConf is the GitHub Enterprise. Well, the ability to connect your GitHub Enterprise instances, and so basically the connection of all that. We ended up refactoring our entire GitHub API, and so that was the main project I've been leading recently, and that's about it. But on to you, Mike.
All right, awesome. Thank you, Rodney. So, a quick background on who I am. I am Mike Gualtieri. I have been in software and cybersecurity for a bit more than 2 decades, and I've been wearing both technical and business hats throughout my career, often at the same time. Oh, Rodney, I'm getting a little background noise. Do you want to mute for a second?
Sure.
Cool. So anyways, yeah, I've been wearing business and technical hats most of my whole career at the same time. Last year, I took on a role as the staff security engineer here at Gatsby, where I'm formalizing and building out our security and compliance program. I get to have a hand in everything from penetration testing to detection engineering to vulnerability management, risk analysis, and implementing our SOC 2 compliance program, and everything in between. So it's a big job, and I have to say I absolutely love it. I love the team. I love being here. Part of my role, in addition to my role at Gatsby, I'm on the part-time faculty at the University of Pittsburgh School of Computing and Information. Specifically, I teach for a program called the Professional Institute. And for that program, I've developed 2 courses, both called the Offensive Boot Camps 1 and 2. Those courses teach students vulnerability analysis and penetration testing. And before Gatsby, I spent 15 years as an entrepreneur where I ran a software and design development firm. I was principal consultant at a offensive security firm, and I founded a children's software technology company built on Linux and open source software. All right, let's move into what we're talking about. Our presentation is broken down into 4 sections today. So first, we'll cover about how to approach securely architecting a web application. Then we're going to get into some of the secure coding techniques that you should be considering for your project development. Next, we're going to get to my favorite topic of the day. Can you hack static? And yes, can you hack a static website? We will see. And specifically in that conversation, we're going to be looking at content security policies and sub-resource integrity. And finally, part 4, some bonus content. If we have enough time to get to it, we are going to cover some OWASP top 10 flaws, how to find, exploit, and test for some issues that we've left in our application. Before we get into the actual demo that we're going to be talking about mostly today, I want to talk briefly just a moment on security at Gatsby, because I think you all find it important. That's why you're here today. Hey, Rodney, I think I get in some background noise again. Cool. So it's obviously security is really important. You're here today to discuss it, to learn more about it, to secure your own applications. So I came here to Gatsby about 10 months ago, like I said, to help build and mature the security and compliance program. And we've done a lot during this time. Last year, we were really focused on the Gatsby Cloud, securely architecting our service to protect your data. I've stressed having offensive security capabilities here at Gatsby. And we conduct regular internal penetration testing and application security testing, in addition to bringing in talented outside penetration testing teams to test our services. We've also achieved our SOC 2 Type 1 compliance this past September, and we are at the verge of our SOC 2 Type 2 compliance, with our current audit window closing at the end of this quarter. Later this year, we're going to be tackling GDPR for our EU customers, and we are going to focus on bringing some more customer-facing security features to both our Gatsby Cloud and our open source framework. So at Gatsby, we talk about security in a so-called shared responsibility model. And this is common among cloud providers. So what it means is that our job at Gatsby is to secure our infrastructure and our service. And we work every day to keep your data safe. So that means your website source code, your digital assets, your builds and deploys. Your responsibility is to develop secure web applications with the Gatsby framework. So that means using best practices with regard to secure coding, things like we're going to talk about during today's presentation, testing your applications for OWASP top 10 flaws, other vulnerabilities, securely architecting your application, and understanding where and how you expose data within your application. So that is the intro. Let's actually get into the content, because that's what you're all waiting for. Rodney, I'm going to stop sharing my screen here. And why don't I kick it over to you, and we will have you demo our little application. Let's see. I think I stopped.
Okay, can you hear me?
I can. Yep, you're all good.
Okay, add stream. All right, so we went down the rabbit hole there. All right, so first of all, it's not just a little app, it is the app. Mike, I'm a little offended that you just call it a little app.
It was a lot of effort to put this together, yeah.
So now that you're getting introduced to the app, right? So we have a little portal. So you'll notice that there are static aspects to this site. So we have a home page, an about page, and then the infamous login portal. So now we're going to go towards some dynamic functionality. So here we have a username, a password, and essentially once a user logs in, you're going to see that there's going to be some change. I want to save this. So now we are logged in. You notice that the content the user is getting now is different. They are logged in. And now we're on this dashboard. You have file 1 and file 2. So if you were to click on one of these files, it will actually ask you to whether you want to download this file, and then we could open it up and find out some very, very interesting things. Now, this, as we see that we talked about static and dynamic, so I'm going to just go a little bit over to the code base. And Mike, let me know if this is too small to see.
I can read it.
Okay, perfect. So here it's a typical Gatsby site where we've separated things, pages, components, React components. And then we have this API folder, which is essentially has serverless functions that will be called to do some of this dynamic functionality that we are requiring.
So real quick, Rodney, I wanted to stop you for a sec. Can you, for folks that aren't familiar with Gatsby functions, with serverless functions in general, can you explain how these integrate into application architecture and what they do?
Yeah, so a serverless function, unlike the name, it sounds like there's no actual server, but the reality is that there is you're able to basically have this compacted functionality. So usually some small and not too heavy workload that's done. And usually you can have this on a third-party server or on your own backend servers, but they're basically spun up and scale up and down as necessary. But they're usually just dealing with stateless functionality, and they're usually just for small chunks of code, and which basically helps with security because it reduces a lot of the complexity. And so with Gatsby, we actually have a folder, this API folder, and then you basically export a handler, and that handler is going to now process whatever activity functionality that it is that you wanna have in your functions. Oh, and there we go. Stop sharing. Ah.
All right, thank you, Rodney. And we have one comment here about maybe if we could try to increase our font size a little more. We'll try to work on that in the background here. So, all right, now, yeah, go on.
Oh, I was gonna say, like before I get into like actually breaking down more of the code, can you like kind of tell us a little bit more about this infrastructure we're kind of setting up? You know, just the data persistence and the cloud, all that stuff.
Sure. Yeah. Let me share my screen again real quick, and we will kick it over to a slide that highlights our architectural presentation. All right. I think we're all good there. Rodney, you see this? I think I don't hear you, but oh, yes, you're muted. Yes, yeah, you see it. Yeah, good. All right, cool. Perfect. So, as Rodney said, there's our application actually has a lot going into the architecture. So, oh, hang on a sec. Rodney, can you mute yourself again? Mm-hmm. Sorry, I'm just getting background noise. All right, so this is our secure application architecture. So what Rodney introduced, what we developed here is a secure document sharing portal, right? You log into this application, and there's these sensitive documents that the visitors have access to. Now, when you're architecting the application, you want to make sure that you're only exposing the sensitive data to where it needs to be exposed to. So if you look at this on the very left-hand side, we have our website visitor, okay? And this is the person just logging in and accessing the documents, probably as part of their work. They are interfacing with a Gatsby website, and specifically the client-side portion of the Gatsby website. So in this presentation, we're going to talk a lot about client-side, server-side information. So the client side is the actual application, the Gatsby application they're using to access the data. Then what Rodney showed in the last little bit there was our serverless functions. So there's dynamic functionality. So we have dynamic serverless functions that do login. They do loading of our dashboard, our profile information. They retrieve the documents that we're trying to access, and they're also doing the logout functionality. This is where the Gatsby website ends and where the additional infrastructure, the power of the application starts. So we've also set up a little bit of infrastructure on Amazon Web Services. So the serverless functions interacts with Amazon Web Services through these IAM policies. So we'll get into that in a minute, what that is. But essentially, there is a user inside the Amazon Web Services that is allowed to use some certain resources. Specifically, we need two resources to make this work. One is a database. So this is Amazon RDS, Relational Database Service. It's just a MySQL server that is holding some information about our application. It's the persistent data about what's going on in our application. And then we have this AWS S3 storage bucket. So it's just basically a place where we can dump files, right? Now, specifically, these are locked down, right? The database server and the file storage server cannot be accessed by anything except the user that we've assigned in these IAM policies. And specifically, this is what we use in our application. So these serverless functions communicate to Amazon Web Services, this backend information through an IAM user, and all that is completely separate and hidden from view from the visitor and the client-side source code. So if you want, oh, are you there, Rodney?
Yeah. I was going to ask, so just to make sure we're all together. So you're saying we have the client side, the server side. and then the IAM policies are basically setting permissions on what a person can access. Is that correct? Am I with you on that?
Yeah, well, yeah, more specifically, what the application can access. So there's almost like, I'm going to say the word firewall, but it's not really a firewall in the traditional sense that there's like ports that you're locking down or things like that. But all this information here is completely segmented from anything on the internet except our application. And that's actually done, like I said, through these IAM policies. So I have a sample IAM policy right here. It's not very fancy, and you actually don't really need to worry about the syntax or anything. This is really just specific to Amazon Web Services. But the point is, we have this user, and the user is called security demo. And we set this up in Amazon Web Services. And by default, that user can't do anything. They aren't allowed to access anything. But what we did was we set up this IAM policy to give it access to list S3 storage buckets, to get objects out of those out of that storage bucket. So that's our files that we're dumping in there. And then we're also allowing it to connect to our database service. So this long string at the bottom is our database. It's a fake one, but this is our database server identifier. So now if we jump back to here, the credentials to access these are held here in the serverless functions. And they're kept secret. Well, we'll get into how those are held in just a little bit. But now, one of the big things that our application is going to do right off the bat is authentication. Specifically, we're going to use JWT authentication. So, Rodney, I'm going to shift it over to you real quick. Maybe you can highlight a little bit more in the code how we're doing JWT authentication and what is a JWT? What is a JWT? What is JWT authentication, and how do we use it in our application?
Sure. So let's backtrack. So you asked what exactly is a JWT, and one of the things I like to think of it as is I like to think of a JWT as like a check, right? So if you think of a check, you basically have to sign the check, and then after a while, if somebody wants to withdraw the money, they have to basically verify that check and then grab then they can grab money out of the account. So we're gonna go into our API folders, and so we're just gonna kind of see where exactly we see a JWT. So here you see that we're going to get a token, and the way we're going to do it is that we're going to use JWT.sign. So this is just, we're using a JavaScript library called JSON Web Token. We're just calling it JWT for short, but this is going to now sign. And if you notice the function signature, you'll notice that we're signing the payload. And then one of the other things that we're going to pass through is this JWT key, which is going to be some sort of secret or some sort of private key that we're going to actually use to verify. This is going to help sign this is what we're going to use to sign this key or this token. And then we're also saying what exactly will be the encryption or the algorithm we want to use to encode this token, right? And so at this point, now that we have signed this JWT, we can pass this forward. So in our application, we're using cookies to pass this forward, and then we say how long is the max this should exist there. And so we'll see in another file how we kind of reuse this. So let me see if we can find JWT in this file. So now we're in another function later on, and we're now saying, hey, I want to use JWT.verify. So what exactly is this going to do? So it will grab that token, right? And then it will use the same key. We'll use the same key in order to now verify this token value. And then it will grab the payload from that token. Based on that token, and now we can use this in the rest of our application, pass it around, pass it forward, and this is now a way for us to interact in different parts of our application in a more secure fashion. And so I'll stop there. Mike, if you want to add anything.
Yeah, yeah. So I really like your analogy about it being a check, because that's perfect. This is actually the first time I heard that. I love it, because like, what was a check? It's a piece of paper that you submit to something that has information that you can do something, right? And and it's signed, right? And it's verified because it's signed, and it has your bank account and all that. And that's the same way. And I really like, if you think about in a JWT, so your payload is what you're allowed to do. It's information you're allowed to have. It's signed through there. That algorithm. So we're signing it with a specific algorithm, like HS 256 or whatever, and that signing is almost like the pen that you're using to sign your signature. And then you can also and should expire your tokens at some point. And that's like if you get a check in the mail and says cannot cash after 90 days, like that's exactly it. So it's no longer valid after a certain period of time. So those are all really important aspects. But there are some other specific aspects to JWTs that are really important from a security standpoint. So yeah.
Actually, yeah, I was gonna ask you about, like, you mentioned the other day about like there being some like specific security issues that come along with JWTs. You wanna dive into those?
Yeah. So well, the first one, why don't you share your screen again? I want you to bring up a terminal. And
sure.
We're going to take a look at our JWT.
The chat is going wild. I like Daniel Lee's comment. I'm trying to share. He says, check yourself before you wreck your application, is what Mike said. So
yes, always check your application security before you go live. That's why we're going to take it as that. So, all right. So we're going to first look at the structure of a JWT. And you kind of went in through this a little bit in the code. There is like a header, there's a payload, there's a signature, but why don't you grab the JWT from our application?
Okay.
And if you bring up your dev console, and by the way, we aren't using any special security tools. You can use fancy security tools that does a lot of this and maybe automate some of this, but I really want you at home to be able to digest the same information. Oh, and by the way, there is a GitHub with this code on it. I should drop the link. I will after I stop talking. But there's a GitHub with the code that we're referring to today that you can actually take a look at the same time. So anyways, my point is we want you to be able to look at this at home without any special tools. So we're going to rely a lot on the terminal and developer console and Chrome Firefox today. So when you log in, Rodney, you get, actually go back to Chrome real quick.
Yep.
And when you log in, just log out and then log back in so people can see. So we're going to log out.
We log out.
It might be a little laggy because of all like the streaming and everything, but yeah, log back in. And then go over in Chrome. You have your development console over on the side. Go over to the application tab, and then go down to cookies, and you already have it up there. And we see we're setting 2 cookies, the CSRF token, which we'll get to a little bit later, and also a token. That's our JWT that we're using to authenticate the user in the application. So why don't you just go cut and paste that real quick.
Okay, copy.
And then put in like a text editor or something so we can see, so we can break it apart. A JWT is in 3 parts. So there is the header, payload, signature, and they're all separated by a period. So we're going to just break up the code into the 3 parts, not code, the JWT.
Okay, so these 3 values, you said header, and then payload, and then what was the last part?
Signature.
Okay. All right. Perfect.
Oh, cool. All right. Now, this is the first thing. Now we're all set up here. This is the first gotcha that people don't understand all the time with JWTs. So, a developer will look at this and say, wow, that's a bunch of encoded text. It's probably encrypted. I got it from the server. I can trust this thing.
Perfect.
So that's not true. So it is not encrypted, but it's encoded. specifically is base 64 encoded. So if you're used to looking at base 64, you'll like look at that in a second and be like, yep, that's base 64 encode. And if you're doing application security testing, the cardinal rule is anytime, well, there might be more than one cardinal rule, but one rule is anytime you ever find anything base 64 encoded, you decode it. So that's what we're going to do now. So Rodney, why don't you take the header real quick, cut and paste that, just echo it to the terminal, and then pipe it to base 64 minus D to decode it. And this is a way to decode in the command line. You can also cut and paste these headers and stuff into a terminal. That is totally fine too. I mean, not in a terminal, in web pages that automatically will on base 64 decode it. So there's a lot of them out there. But anyways, so you decode it, and it turns out this isn't some like hidden text. What this is some it's actually telling, this is the header. It's telling us that we signed it with the HS256 algorithm, and that it is JWT, which is not surprising.
Yeah.
So more interestingly, though, let's do the same thing for the payload section. Just don't skip the period and then get the rest. Echo it, pipe it to base 64.
Base 64-D. Oh, echo.
Yeah.
Base 64-D.
Okay.
Oh,
there you go.
Okay.
So in here, in our payload, it's not encrypted or anything. It's all in clear text. And that's one thing to really keep in mind. Anything you put inside a JWT is available client side. Your users can read it, and an adversary could potentially read it. So in here, we've added a user ID, a username, and there's some other information that's not really important to us right now. But if you were to put something sensitive in here, like the user's password, or possibly something like, I don't know, like an AWS token that you think can be client side, but you really should never use client side, that's a really dangerous thing. So you have to keep in mind everything in a JWT is clear text. It has integrity to it, right? We can't tamper it because of the key. We're signing it, but we can read everything inside it. So we can trust it, but it's open. Now, that's one aspect of JWT security. I just mentioned the second one, I hinted at it, is that you have to make sure that your signing key is very secure. If anybody gets your signing key, they can forge JWTs for your application. And Rodney, share your screen again real quick. I want to show, let me bring up the example environment variables file.
Yep. Okay, so example. Yep.
All right. So in here we have this line. Now this is obviously our example one. We have a real one that we have our application, our items that we're using to authenticate to their serverless functions. But over here we have almost at the bottom we have JWT secret key, and above that. So why don't you just show? It's like a long string, right? It's like it's it goes on and on and on. Yeah, okay.
700 characters.
Yeah, 700 characters. So if you're gonna make things secure, you might as well make it really secure. So the command that we use to generate this is actually right above it. It's just there's nothing special about this JWT and nothing special about this command, by the way. This OpenSSL command here just generates 512 bits randomly and base 64 encodes it. Okay, that's a great way to generate JWT keys. They're a secret. Another way of generating really good JWT is to take your hands, bash them on your keyboard until you have a long string, and that's pretty good too. The important thing is the length, right? Because if you made your JWT secret something like secret, password, test, that is not, so you can crack a JWT just as you would crack a password. And once that key is cracked, the attacker can then forge JWTs and become anybody or anything in your application. So you have to make sure that this value stays server side, it's a secret, and that it's long so you can't crack it. Now, the other, that's pretty much like the highlights about JWT security. I think we already talked about timeouts. That's really important. And if you're passing these in via a cookie to the front end, there's ways to do that. You can use authentication and bearer token, or you can use secure. Any way you can get it to the user is okay, I should say. If you're going to use a cookie, you should really set your cookie security policy to be HTTP only and same site. We actually have this commented out in our development example because Rodney and I are all over in different development machines. But in production, we would set those cookie security headers. So now you have the environment variable file open right now, though. And I think it's a really good transition point to talk a little bit about environment variables, because some people might not know what they are. Like, what is an environment variable? How do you use them? And what is that one really specific thing that relates to Gatsby that we need to make sure everybody knows?
Yeah, so let's start with that, the term, right? So when we talk about environment variables, right? So the word environment is key, and it is the fact that most of us, typically when you have a production scale application, you may have different environments. For example, local, maybe staging and production, and each of these may have different configuration settings. So what do I mean? So maybe for your local database, maybe for your local dev environment, you may have a dummy set of data in a database somewhere so that it doesn't actually mess with your actual users. So you may need to have an access key or an ID or a password for that instance, or even a host that directs the application to that specific instance. And so this would be a good use case for an environment variable, that these are values that within a specific environment we want to inject within our program, and then we can actually use these during the use of the application. Now with Gatsby, typically you'll see different people do different things with applications, and one taboo that you should watch out for is on line 12. Typically people have these Gatsby underscore variables, and it's kind of like to say, all right, these are all our Gatsby environment variables, and it has a use case. But one thing you should note that is that all of these Gatsby underscore environment variables are public, which means that they're available on client-side code. And the use case for this is, like, typically if you have something like, I don't know, like maybe an analytics platform, and you basically need to, on the client side, you actually need these public environment variables that will help with your analytics flow. This would be a use case for using these, but generally in most of your code, you want to avoid this Gatsby underscore pattern.
Right. Yeah, no, that's perfect. That's perfect. So, I just really want to highlight that point, that environment variables are good. You should use them in your application. You can separate, you don't want to be putting hard-coded passwords and tokens and things in your code. That's what an environment variable is for. But all your environment variables are secret except for those Gatsby underscore ones, right? Those are specifically to be accessible during the build time, that are pushed to the client side of the code base. So yeah, perfect, Rodney. All right.
What's next on our agenda? I know we've talked about environment variables, a lot of things. Do tell me what's next, Mike.
Okay, we are next going to talk about caching data and secure logout. So, and how are we doing on time? We're doing pretty good on time there. So, and a reminder, if you have any questions, just drop them in the QA section, and we'll do our best to address those during the presentation. Otherwise, we'll just keep on going until we're done. All right. Secure caching of data. All right, so let me share my screen again real quick.
Yep.
And I want to share, I think I want to share, I'm not going to share my whole screen because it's probably going to be a little too small. So yeah, let's look at the browser screen then. Okay. Oh, let me add it to the stream. Perfect. All right, cool. All right, we're going to go to our application here, and we're going to log in. And now Rodney already mentioned, if we go to this application tab and we poke around here a little bit, we have our cookies that we set when we log in. So we have the CSRF token, JWT token, and then also in local storage, we are looking at, we are also saving our
Can you
CSRF.
zoom in just a little bit, please?
Let's see. How do I do that?
Control plus, I think, should be.
I'll try that. Yes.
There we go.
Is that better? All right, cool.
Yep.
Yeah, so we have this, we're also setting our CSRF token here. We'll talk more about CSRF tokens in just a little bit. We also have this data cache here. All right, so this data cache is information that we're storing locally that helps us, our application be a little more performant. So when you log out, let me just log out again. And we're going to log in again. And the first time we log in, we see that we have those little spinners. All right. But if we were to like go to the home page, go back to the dashboard page, it's really quick this time. That's because it's relying on the cache data that we have, that we already have stored in our application. Now, cache data is good. You should use cache data. Actually, Rodney, like why? Like highlight like why. I think I probably just mentioned about like performant web application, but like I guess like maybe you just talk just a second about like data caching and why it's useful.
Yeah, so basically in a 1-minute brief version, it would be that, you know, when you want to cache things largely because caching allows you to quickly retrieve data instead of like certain data that you may not want to actually, let's remove this from stream for a moment. So basically, whenever you have data, right? So in our example, every time we would want to get the user, we would have to go to our RDS instance, right? Now, caching just allows us to say, all right, we've added a layer of basically usually ephemeral data that we don't care if it gets lost on a reboot or whatever. And then now we can now say, all right, data, instead of doing a database call every time we need this this call, we can now just use this cache, this layer that's standing in between our database that usually has the data that we've been calling a lot. So I'll pause there.
Perfect. So let me pop back over here. So cache data is good. You should cache data in your application. I think we established that. The thing about cache data, though, is that you should never trust cache data. And I want to highlight that just with a really quick example here. So I'm actually going to go into my code really quick. And let's see, you can't see that. Maybe what I should do is just swap. Maybe I can share. I'm going to actually remove this from the stream. I'm going to stop sharing. I'm going to share. I'm going to share my terminal real quick. Here we go.
Cache data needs love too, Mike. They need trust and acceptance. Cache data needs love.
And Rodney, can you add that to the stream real quick? Because I'm on the wrong screen.
Yep.
Oh, we're all good? All right, perfect. Yeah, so, all right, here's our project. And I just wanted to show the source code what I'm doing here really quick. So if we look at source, and I dropped the link in the chat. So this is on GitHub. You need some backend infrastructure to run it, but you should be able to follow along with the source code when we're looking at things. So if we look at specifically, let me bring up my example files here. So we're going to be looking at the dashboard real quick. And if we go to source components, dashboard, and at the top here, there's this function here called get data. And when I say function, I don't mean like a serverless function. It's just a JavaScript function that's in our front end Gatsby client code. This is what powers the dashboard, right? So we're coming in here, and around here, we're checking if we're logged in, we're going to see if there's cache data. If there is cache data, we're going to populate the dashboard. Otherwise, we're going to show our spinners. And as we go on now, we're going to automatically refresh the data after this with a call to our serverless function, API dashboard. And then this is going to take the data from the database and then put it into the application. So I'm going to show you though what happens if we don't cache this data, just to highlight why we can't trust the user code or the client side data. So I'm just going to add a return there, save it. That should rebuild it. I'm going to remove this from the stream, and I'm going to go back to my web browser real quick.
Okay, Mike, can you hear me?
Yes. Can you hear me?
Yeah, I don't know if it was that I got dropped or you. Can you hear me now? Are we good?
I can hear you. Can you hear me?
Yes, I can.
They should add some caching to the video stream, huh?
Yeah.
It really is heavily cached, but you know, we're doing a lot of stuff with like streaming and screen sharing and swapping strings. So we will make do.
Let me add that to the stream. Yeah, we're good.
We're good. Perfect. So let's go back to our application again. So let's instead, so this data I mentioned should not be trusted. So anybody can access this data who has access to the workstation. Anybody can manipulate this data. So let's just real quick go like this. We're just going to change our cache data to be admin@test.com. And then we're going to change this to be admin user. All right. And we're going to go away from this page, and we're going to come back to the desktop or dashboard. And now I'm an admin, right? Right. Wrong. So we aren't an admin in application. So
I feel the power.
So I mean, if your application is poorly architected, this would happen, right? So my point is, if you were depending on data here, if you change this user ID to be the admin's user ID, and then we're using this as part of your serverless functions to retrieve data instead of your signed JWT, that could definitely be a problem. Well, in our case, it turns out this is just the presentation layer, and we've done things properly, right? We aren't trusting this data. We're just displaying it. So our changing of these parameters to be admin is essentially just like the equivalent of doing like a right click and view source and changing the source, right? The client can do it. It doesn't change anything in the actual application. So what we're going to do here is I'm just going to, instead of swapping these screens around and juggling the screen sharing, I'm just going to really quick remove that return statement so our application refreshes again. And now it already refreshed, but basically now when we go here, yes, it's using the cache data, but it's refreshing it. And now if we try to change it, okay, I'm admin. Let's like go back out here and go to the dashboard. You saw admin for a split second, but then it updated to the user. So my whole point of this is, let me drop the screen share real quick. And let's see. Oh, Rodney, I think your camera's off, but you might know that. The whole point of doing that is to highlight that you can never trust data that's client side. Anything that the user can manipulate is potentially tainted. You can most certainly trust your JWT, because if they tried to tamper with that, it would break the signature, the signing of it, and then it wouldn't be accepted server side. So moving to our next topic here, which is securely logging out of an application too. So it's kind of related to this as well, but let me present again and bring up my terminal. Now, we highlighted before that when we signed into the application, it's setting some tokens, it's setting some cookies and some other data. So how do we properly log out of an application? All right, we're securely signing in with our JWT. We better make sure we're securely signing out. And this is a real common mistake I see a lot, where the user signed out only client side. So if we look at our code, if we go to source components, no, I think it's source services and auth, if I'm not mistaken. at the bottom of this file, we have this logout function, this logout routine here. All right, when a user clicks that logout link at the top of the file, what happens first is we are removing their cookies, right? Or actually, we're destroying their session storage here. We're removing their data cache. We're removing the CSRF token that we previously stopped. And then if they are logged in, indeed, we are going to then log them out. And what happens is we're going to call our serverless function API logout. All right. So let me bring that up real quick and show you what's happening in that function. All right. If we walk through this a bit, when we start to execute this function, the very first thing it's going to do is try to clear our cookies. And removing those cookies is going to sign the user out client side, all right? But the very important thing that it's going to do next is sign them out server side. So how do we go about doing that? Well, when we actually logged them in, we were setting this thing called a CSRF token. Now, this is going to be used for to prevent CSRF attacks, but we can also use this as part of our authentication routine. Every one of our serverless functions has a routine kind of like this in here that you see where we're first authenticating our JWT. And Rodney already talked about this, right? We're extracting our JWT payload. We're making sure that it's actually a valid JWT. If it is, we are going to continue on. Otherwise, we're going to dump them out with like a 401 unauthorized or a bad request. Next, we're checking our CSRF token. All right. And this is just a secondary authentication check for a very specific vulnerability. But this CSRF token, we're actually storing in a database. And you could store some other type of identifier in the database, but this was a really convenient way for us to manipulate a piece of data that the client has access to and the server has access to that can verify each other. So to log the user out server side, we simply just remove the CSRF token. So we're running this SQL query here where the user ID is what was in the payload. We're just blanking it out. And when that happens, the user is signed out server side. So I want to actually highlight what happens here if we don't log out, securely. So what I'm going to do without changing my screen share is I'm going to just grab, actually, no, I will change my screen share because I think it's important for you guys to see. So bear with me. I just have to do some juggling here. All right, we're going to do that. I'm going to present, and I'm going to present my window here, and we're going to look real quick at our application. And because our session time is only 10 minutes in length, I'm just going to sign out, sign back in. Okay. When we've logged in, it's going to let's see. Yeah. When we log in, it sets our data, our cookies, and these cookies are passed with every request. So we're going to go over here to our network tab just to see what's going on when we click around. I'm going to clear this out, and I'm going to go home, and I'm going to go back here, and it's going to create a post request here at the dashboard. Okay, so when we click on this dashboard link, it's calling a serverless function that returns our user profile data. And you can see that here at the bottom of the screen. It's this JSON data. What we're going to do is take this and we are going to copy it as curl. And then what I'm going to do is execute this. I have to juggle my screens again. So all right, if you've never done this before, if you copy something as curl from Chrome, what it does is give you a curl command that is the exact same thing that would be sent by Chrome to the web server. So we can just cut and paste this in. And there's a lot of junk in here, all right? There's a lot of headers. Important parts is we're doing a curl, our host, API dashboard, Our cookies are set, which means we should be authenticated to the server. So let's hit enter here, and we get our data, just like how we would get it in Chrome. So this is what's supposed to happen. This is perfect, okay? Now, what we're gonna do real quick is log out, and I'm not gonna juggle my screens to do that, but I'm gonna go to dashboard really quick. I'm gonna log out in the application just by hitting the logout link. I'm gonna come back here, and I'm gonna try to run this again. And if all goes well, it shouldn't work. It doesn't. If you notice, it just gave us a blank response. So so you can actually see what's happening. I'm gonna do a curl -v, and that's just verbose. And if you look here in the headers of what it actually sent back, we actually get this 401 unauthorized. So this is perfect because we removed our CSRF token server side. All of a sudden, the server has lost information about our session. So even though our JWT is still valid, it is not letting us communicate with the application. Now, what we can do also is break this. And so I want to show you really quick. If we go to source source services auth, where we're actually calling this logout. Right here, let's just say we're going to log out, but instead of fully logging out, we are just going to comment out this return function here. Actually, no, that's not what I want to do. I think what I want to do, I think we'll better highlight this.
The whole block?
Sorry, what, Robbie?
I think it was just the whole block and just leave the, like everything on the server side. We're going to comment out.
Okay. What I'm going to do is I'm just going to instead return my function here. So let's say we on the server side, all we're doing is destroying these cookies. And if I do a return here, I think we should be good. I'm going a little off script here because I think this actually highlights this issue a little better. So let's go back here, and I'm going to get another. I'm not going to swap screens because it takes a little bit of time here, but I'm going to log out. I'm going to log in. I'm going to grab another one of those fetches curl from the command line from Chrome. Let's see. Ooh. Here we go. All right, I'm copying. I'm doing Chrome. I'm just doing that. Okay. So we're logged in our application again. I should be able to get this, and it should give me back the dashboard information, and it does. Okay. Now, what we changed in the code is to remove the server side logout. So I'm going to log out of my application. I'm just clicking the logout button right now. You'll have to take my word for that. And I should be logged out, right? But the only thing that happened was that our client-side cookies were removed. So we saved our cookie beforehand. I have it in this curl command, and anybody who has access to this token would also have access to this session. We're going to run it again, and we still get our data. And the reason we get our data is because we have not logged ourselves out server side. So I'm going to pause there real quick. I'm going to swap back over to you, Rodney. I'm going to remove myself from the stream, and let's see.
Yeah. So you've mentioned a lot about CSRF, I believe. Maybe we could talk a little bit about what that the CSRF token is used for, and what exactly is CSRF?
Yeah, so we're using the CSRF token in our authentication routine as a secondary check to make sure that the user is who they say they are. Now, CSRF is a specific vulnerability. It stands for client-side request forgery. It is essentially when an attacker can manipulate the user to make an action client side. So well, actually, before we go into a little demo on this, I should say that CSRF is very closely linked with the vulnerability class called XSS, or cross-site scripting. So cross-site scripting is when a piece of JavaScript code is injected client-side and executes on the client's application. So it executes on essentially on the victim's machine. Now, we could talk about cross-site scripting. I could do a whole hour presentation on on cross-site scripting, the different classes and how it works, and all that stuff. But I want to stress that it is a dangerous vulnerability. And let's see. Oh, Rodney, you're sharing your screen. Oh, okay, yeah, I didn't know what happened. Rodney, you're sharing your screen. No, that's good. I want to highlight that cross-site scripting is a very dangerous web vulnerability. Essentially, if you can execute arbitrary JavaScript in a client's web browser, you can do things like steal their password. You can steal their credit cards. You can steal their browser tokens, or their session tokens, their cookies, and things like that. And if you can get any of that, you can essentially become them in the application. So the nice thing, though, about cross-site scripting and Gatsby is there is a lot of protections in the Gatsby ecosystem, in the React ecosystem, that actually can save you from a lot of the bigger cross-site scripting issues. And Rodney, why don't you kind of dive in a little bit for a second on what we can do to sanitize our data in React? I can't hear you, Rodney. But... Oh, Rodney, you're muted. Okay, there you go.
Okay, there we go. All right, so if we dive into, for example, this dashboard file, right? So one of the things you'll notice is, with React, let me just say, const script is equal to script alert 1, right? So this is a classic
it's a classic cross-site scripting. And I want to highlight here real quick that Rodney's, like, cross-site scripting isn't when you add yourself alert 1 or like instead of alert 1, just read that as steal my credit card there. Like, no, the developer's not doing that. But this is just a way we can really quickly show you what cross-site scripting is if you aren't familiar with it. But if the user was able to manipulate their username, like you allowed them to save their profile, and instead they send it to be a JavaScript instead of their name, then that would be a problem, right? So I just wanted to highlight that.
Yeah, so one thing that's very interesting about React is that, let's say we try to run the same exact functionality. There's an interesting thing about React in that it will sanitize all inputs given by a user. So, for example, whenever you're using JSX, that is, and so basically this script, it's basically whenever it sees HTML input or HTML tags as input, JSX will basically sanitize that. The way you would actually end up getting around this would be using a property called dangerously set inner HTML. And so, but even in those cases, there are libraries that can help in terms of sanitizing input there. And likewise, there are actually specific cases where you might actually, like, for example, if you have opening links and things like that. In fact, I think, Mike, you had an example in here. There we go.
Yeah, if you go up, where in Git file, we call this DOM purify. And the reason I'm doing this here, so we can't use JSX syntax here in this routine, because we actually need the user's input. And we shouldn't trust the user's input, but we need to use the user's input, right? So this little Git file function here executes every time the user clicks on one of those files to download. But because it's inside a JavaScript file, we have to access this raw variable. we have no way to sanitize it with JSX. So we're using this DOM Purify library, which is part of React, to sanitize the file first. And it essentially does the same exact thing. If we didn't do a DOM Purify here, if the user manipulated that file parameter where it executes down, where it's injected in line 22 there, that would be cross-site scripting. But we fixed it because any strings, any arguments in there that would be a script or anything else are all sanitized out.
Okay, so I'm going to stop sharing my screen. But you know, onto, like you mentioned this concept within the context of CSRF. So I'm pretty sure everybody now is just like on the edge of their seats. Please, Mike, tell us, what is this all about?
How awesome is CSRF? So CSRF is an extremely common class of vulnerabilities on the web. So I mentioned in the start, client-side request forgery. And it is when you trick the client to take an action on behalf of some, you know, some adversary out there. So, so the best way to highlight this, it's hard to explain unless you actually see what happens here. So let's demonstrate it. So Rodney, why don't you share your screen again? And I will walk you through a little CSRF demo that I created. So what we're gonna do is we are going to steal, well, we're going to access the user's profile data with a phishing attack. Okay. Now there's some complexity to this. We'll talk about it at the end. But essentially, what we're going to do is visit /API. Well, actually, what I'm going to have you do is comment out some code first. So if you go to API dashboard.js, and if you go down to line 41, we're going to remove our CSRF check. Just comment that line out. And this is just making sure every time we access the dashboard that we aren't checking our CSRF. If it's wrong, if it's the wrong token, that we're just going to go right through this thing. So what this little routine here is check valid CSRF token. This is something that I wrote that essentially just looks at the CSRF token that's passed by the client to the server and sees if it's the same one that's stored in our database. And what we can do, let's go back to the source components dashboard, Rodney, because I want to show how we're actually adding the CSRF token in here. So if we go down to get data, this is perfect. You'll see in here that we're taking our CSRF token that we stored in our local storage, and we're adding it as a get parameter to the function that is being called, to the serverless function. The big reason we want to do that is because we can't trust cookies in this scenario, right? The cookie is what's getting us into trouble. So what happens is when you're logged into a website, you have an authentication token, and that's set in a cookie, and that's what we're doing here. The problem is anything you access on the website, if you want to or not, if you're tricked to or not, is bound by that cookie. If our CSRF token was inside that cookie, then we would just pass it along to the attacking, CSRF call. So even though we're sending the CSRF token to the user initially via a cookie, we're saving that in local storage. You don't have to do that. That's what I'm doing. But the most important thing is that what we're doing is sending it back to the server on every post request to the serverless function. We're setting that as a parameter. So I want to highlight that. But in dashboard functions, we just disabled it, right? There's no check anymore. So I want you to go to your browser and go to, let's access the function just raw, just go to /API/dashboard.
Oh, hold on 1 second. Dashboard. So.
Oh yeah, remove that. It doesn't really matter, but.
Yeah. Okay. So you said go where?
We're just gonna, because we removed our CSRF token, we should just be able to access the API without passing any tokens. So log in and then just go to /API/dashboard.
Okay. /API/dashboard. Ooh.
All right. And okay, there you go. You know, that's that same function that we saw before, right? It's super, you know, we were, this is what we were getting with curl, where we're used to this data now. Now, the reason you're able to access this is because we disabled our CSRF check. And just go, for just humor me for a second, go back to the terminal, remove the comment on that 401 return. So it's /API/dashboard.js. And then just let's check the CSRF token. Now, just so people can see, when we add this back in, we try to access the function directly, it should bump us.
Okay, so let's try again.
Yeah.
Oh, no.
Yeah, so it's a little small, but if you can, you can see this page is not working, but the little small text, it should say return to 401 error, 401 unauthorized. So perfect. That's what we want. So that's why we have the CSRF check. So we can't access these APIs that could potentially manipulate data without passing the token. So, all right, now go back, comment it out again, because we're going to do our little attack.
Okay, comment it out.
And I'm going to log into my server real quick. I have another server that's running some stuff. All right, so I want you to go to that URL, that magic URL I sent you before. Oh, actually, just let's make sure with the CSRF token gone now, let's just make sure that's working. Can you just hit reload here that we can see this, that it's not protected anymore?
Yeah.
There you go. Yeah, so all right, so the CSRF check is gone now. The data is not protected. So anything that tricks the user into loading this URL is going to hit our serverless function. So what I want you to do real quick, we're going to look at this in a couple ways, but I want you to go, just open up another tab and pretend I just sent you like a phishing email or you clicked on some weird link. You're going to go to mike-gualtieri.com/CSRF. No, I think it's /demo and CSRF.demo/CSRF.php, I think. I know it's blasphemy. I coded this in PHP, that this the phishing thing. So, working. Oh, you probably had my last name spelled wrong. Gualtieri.
I before E.
All right, there you go.
No.
It's a little small, but it says, ha ha ha, you've been fished.
Mike, I thought we were friends. This is how it is now? Okay.
All right. So now I want you to bring that back again, and I want to actually show everybody how it hits the server profile. If we can look at I basically want to see the browser, and I want to look at the Gatsby function output server side. Oh, let me add you back to the stream.
Okay.
Perfect. All right. So that's our Gatsby function. Why don't you add some like spaces or something in there so we can, or I don't know how, can you show them side by side? Is that possible?
Yes. Let me pull this. And well, okay. Okay. Let me do some juggling here. Okay.
All right, cool. Now I want you to reload that phishing page again there. And okay, you saw here in the side that it was executing the function. And actually, I think you might have gotten logged out there, Rodney, because it didn't return all the data.
I see. Probably timed out.
Yeah.
Okay.
You just log back in, and then all right. All right, then once it's set up here, why don't we reload our little demo URL. Now the point, what we're trying to show people is that when somebody is hitting this phishing link, it's actually automatically hitting our serverless function as well. And there you go. You can see how you've been phished. And you saw on the other side of the screen that Rodney had there. And let me just make it a little bigger real quick. On the other side of the screen, and do it one more time so people can see. So it was probably a little small. There you go. It's maybe we got logged out or something. The point is, though, you can clearly see there that when we're hitting that URL, that it is executing the serverless function. And the thing is, so there's some complexities to CSRF. And let me remove you from the stream real quick, Rodney. So, or we could just go back like this. Yeah.
Okay.
Let me just so they can see us because we're talking. So there's some complexities to CSRF. Actually, if you go into that phishing page, Rodney, and just like open up your browser, like do a view source.
Yep.
Yeah, you do a view source on that, and let me bring it a little bigger again. You can see there's nothing fancy here. This phishing page, it's nothing. It's not doing anything real. We're just making a fetch call to this. And because of how it's set up, we actually have to use no cores. So in this particular example, we actually can't retrieve the data, but what we can do is act on the user's behalf. And specifically, what we could do is we might not be able to see what we're hitting, but we can manipulate the user. So if you wanted the user to place an order, you can send them a CSRF and have them place the order because you don't care what the output is. You just want it to happen. You can change the user's password, for example. So anything that would require that the user to make a interaction on a negative interaction on behalf of themselves, that's what CSRF is for. But as we saw, if we add that token back in, it really locks down the call to the back end. And unless the attacker has the CSRF token, which would be very difficult to get, then it shuts down the vulnerability. Where this becomes, tying it back to cross-site scripting, where it becomes really virulent is when you can inject code client side and then also abuse the CSRF. Because if you can inject code client side, you are in the same origin in the browser. And in that case, you can steal the user's cookies. You can get all their profile data. You can steal those secret files. So that's why the two vulnerabilities go hand in hand. Not having CSRF alone is very dangerous, but both are extremely dangerous. So we are sitting at about 12 minutes left, and I really want to get to it doesn't look like we're going to have time to look at our OWASP top 10, but we will have time to do this topic, which is probably my favorite, Rodney. Why don't you share your screen again? And we're going to do, so first I should say, so our next topic here is who hacks static. And Rodney, do you think you can hack a static website?
No, Mike. I refuse to think you can. I refuse to think you can prove me wrong. Static is the way. Static cannot be hacked. Any questions? And also the bulls are trash. I just needed to put that out there. But anyways, static.
We've been through the presentation like 3 times, and Rodney is fervent that we cannot hack static websites every single time. But anyways, all right. So it depends what you're talking about. Static, right? If your website is just static HTML and static assets, there's no dynamic code whatsoever in there, then, well, you can't hack that unless you breach the server and modify the files, right? But that is definitely not how modern web applications work and how they work in 2022. There's a lot of JavaScript, and especially in Gatsby, there's JavaScript as well. So where it gets dangerous is when you have third-party JavaScript you're including into your application, right? And this happens all the time, right? We might have, we might need to include a remote font, a remote style sheet, a remote script, a marketing pixel, whatever it is. We often rely on third-party resources that are held on servers not under our control. So what to do about this? Rodney, why don't you go share your screen and we'll dig into a little bit about how this works. Oh, let me see. Let me add you to the stream. We're going to take a look here.
Okay.
All right, perfect. For this,
we're good.
do is bring up layout. Yeah, or you already got it here. So in components layout.js, we have in here what's called a React helmet. And the helmet is essentially just adding different different components to the head section of our website. All right. And in here, I've included some third-party resources. Specifically, I'm including the Bootstrap CSS files. I'm including Font Awesome for some interesting icons. I'm including the Google fonts in here to make it look nice. Now that's all normal. And I know, by the way, that there's better ways to include Bootstrap and Font Awesome and stuff in Gatsby, but we needed something to load for a third party. Thanks for expanding it like that. So we needed something to load third party that was safe. So this is what we're doing. So, so pretend this is like your marketing pixel or something like that. Now, if you look in here, what we're going to talk about first actually is content security policies. So I want you to go up a few lines, Rodney, and there's a commented content security policy that's called restricted CSP. And I want you to just add that to our React helmet.
Okay. What are you about to do this time? You stole my credit card information last time. I don't know if I can trust you. I don't know if our friendship's on the line.
It's going to be later. All right, so we added our content security policy in here, and this is a really restrictive content security policy where our default is we're only going to trust ourselves, just the static website. So go back and reload our website source.
Okay, so let me go to this page. So if I go to the home page and reload,
there you go. All right.
Oh.
So this is like really, it looks really broken here. And if you bring up your developer console, you can see why, right? We added a really restrictive content security policy. What a content security policy does is it prevents the browser from loading content except for where you have specified it should load content to. And we just see all this red. If you scroll through there, it's not loading our Bootstrap. It's not loading our Font Awesome. It's not loading our Google fonts. It's not loading parts of Gatsby in here. So, all right, that is it on its highest setting, but I created a nice tuned content security policy here. So why don't you bring up the source code again, and we're going to remove the restricted policy and we're going to add the good policy.
Okay. Okay, so remove this, and then we have a good policy right here. It's kind of long.
It's really long, and I'm not going to lie. Content security policies can be pretty complex. The browser kind of helps you though. So if you're going to create a content security policy from scratch, first know there's different sections of it. So we have our default source, and adding some local development machine stuff here. But if you scroll a little bit further over, Rodney, you can see script source. And we see that I'm including something for my website, which we're going to add in a second. Ignore unsafe eval for this right now. Style source, we're loading Bootstrap. We're loading our fonts. There's font sources. So these are things that we know we're going to load. So what I recommend, if you're creating a content security policy, start with a restricted policy, add in the resources that you know are going to be present on your site, and then it's always going to be more. You have to just work through one by one until you have no more warnings in your development console. But this policy should be good for our website. So if you hit save now and go back to the web and hit reload, we should be pretty good now. It should just load without any issue. Okay. And it's perfect. It's just like not having one there. Good. Yeah. So that is content security policy. But the other half to this, and it's easier to comprehend, and it's super powerful, is sub-resource integrity. So go back to the source code real quick. Now you see, I've actually already added some of these integrity hashes. You see integrity SHA-384, integrity SHA-512. What this is, it's a SHA hash of the file that we're pulling in, not the URL, but the actual file. So the contents of bootstrap.min.css computes to that SHA-384 hash. If I add one space to that file, if I do anything to edit it, if I inject something that steals credit cards to that file, the browser is automatically going to say, nope, we are not going to load that, and we're done. So let's highlight this real quick. I have another include that you can add above from my website.
Yep.
Yeah. And this is just a script. And so I want to highlight, so these types of attacks are very common. They're in a class of attacks that's called Mage Cart. And Mage Cart is essentially
That's a cool name.
Group. I'm sorry, what, Rodney?
That's a cool name. It just sounds like a cool attack.
Security researchers came up with that. But Mage Cart is not one group, but it's probably several groups of criminals out there that breach third-party JavaScript includes and then inject code in there to usually steal credit card numbers. So there's been a lot of high-profile Mage Cart attacks over the years. One that comes to the top of my mind, it's not the most recent, but I've just thought of it right now, is British Airways was breached several years ago. A little piece of JavaScript was added to a third-party include. So their website wasn't breached. The include was breached, and it loaded some JavaScript to steal credit cards. So if we load this right here, this is just a mimicked third-party include. Let's call it our marketing pixel. And if we load this, it should work fine, right? We have a SHA-384 hash. It's all good. I already computed it. If you hit reload here, we shouldn't see any problem at all. It should just load demo.js.
Let's check in our resources. So we would want network tab. It's the problem with making everything bigger.
Everything's small, yeah.
Okay, so demo.js.
Yeah.
Okay.
And there you go. And it's all right, I've already had my attack queued up here, but it's just essentially an empty JavaScript file that has a comment there. Now this is what we're going to do, Rodney. We're computing the hash. And nothing bad is happening here. We're just loading this file. That's a comment. There's nothing to worry about here. I'm going to change it. While I'm changing it, Rodney, I want you to just bring up a Chrome incognito browser, just in case the JavaScript got cached inside your browsers and ruins our demo.
Demo is most important, you know?
And
not my profile data or anything, just the demo.
Oh, wait. No, remove it and go back because I didn't have it ready. I just got it ready.
Oh, okay.
Close incognito, bring incognito back.
Okay. Close. Was I supposed to change something from the code for this or no?
No, I changed it. So now, all right, we loaded our site. Everything looks fine. Bring up the developer console though. And go to the actual console output.
Okay.
And there you go. I manipulated this file server side to inject some code. And now the integrity is wrong. It's not computing the same hash because we changed the file. Now, what I want you to do finally, Rodney, is just close out this incognito window, go back to the code, and we're going to remove the integrity hash.
Okay, so on this script, remove integrity hash.
So now we're just going to
come back over.
Yeah, we're throwing all caution to the wind. Why don't you I'll bring that back up in incognito just in case it got cached. We're throwing all caution to the wind. We're just going to load JavaScript from whatever source we want. No one cares. There you go. This is a cross-site scripting. And then, I should change it to this. I should change it to this. This will steal your credit card.
No. What? All
right, reload it again, Ryan.
Let's see. I don't know if I.
You know
what?
We're
done.
All right.
We're
so
done.
Obviously, it's just an alert pop up. But what the point we're trying to convey is that without the SHA hash, that remote file can get manipulated by any threat actor that can breach that server. And if you're loading it onto your website unchecked, without a content security policy, without sub-resource integrity, you could run into problems. So we are pretty much at time here today. And we planned a few extra things in case we went over time to look at OWASP's top 10 flaws. Unfortunately, we're not going to get to those, but folks that have our GitHub repo, there is a vulnerability we added in there for SQL injection. There's a vulnerability we added in there for broken authentication in IDOR. We're at time right now. So if folks want to stay extra 5 minutes, I can just highlight what OWASP top 10 flaws are maybe. But maybe we'll do that and just like spend extra 5 minutes and then dump off after that, because we want to be respectful for any other talks there. Sound good? People in the chat like that idea?
Yep.
I think there's a delay, but here I'm going to
put your question.
And if anybody has any questions, we will stick around. We'll stick around as long as you guys don't have questions. Let's just do share screen real quick and present. And I'm going to add this to the stream. Where is it? There we go. Add the stream. So real quick, we found a couple of vulnerabilities just to highlight some common web flaws. So if you aren't familiar with OWASP top 10, do become familiar with it if you're a web dev. OWASP is an internet nonprofit that is all about web security. They have a number of projects under their portfolio, but the most prominent is the OWASP top 10, which is the top 10 most exploited and most commonly found vulnerabilities on the internet. They've been doing this for a number of years. It started, I don't exactly know when it started, but I know there was one in 2013, there was one in 2017, and the latest is 2021. So we can look here, the flaws we're actually going to highlight were going to be first, broken authentication, which fits into the top 7 identification and authentication failures. And we made an error in our documents that was going to allow us to access our serverless functions without being logged in. So the point there was to ensure if you're doing application security testing, you should always test everything that a user does logged in, test that logged out, because you might surprise yourself that one of these things is disclosing information or returning data that could be important to an adversary. The second one we were going to do is called IDOR, indirect object reference. And if we saw in our dashboard earlier, the user had access to file 1 and file 2. There's actually 5 files. And as it turns out, even though we were authenticating our user, we weren't checking to see what files they were allowed to access. And this IDOR is really common, right? So if we were to trick the server into saying, well, I want to see file 3 and 4 and 5, it would have gladly sent those back to us, because we made an error in our logic where even though we were checking to make sure that the user was valid, we weren't checking to make sure that they also were allowed to see the file that they were looking for. So we had a fix in there to do that. And that would actually fit in the top floor, broken access controls. Broken access controls can be a variety of things, but that being one of them. Injection, so we were specifically looking at SQL injection, but injection flaws could be anything from remote code injection, remote command injection. Obviously, cross-site scripting fits in injection as well. We were going to demo SQL injection. And my point there wasn't so much the SQL injection that we're demoing, but I really want to highlight when we looked at the cross-site scripting and we looked at the SQL injection flaws, the same thing is common. We need to sanitize user data before we trust it. And even better than sanitizing it yourself is using pre-built libraries that do it for you. Now, there's probably some genius developers watching this, and if you can come up with a cross-site scripting library that meets every case, build it, people will use it. But if you aren't super familiar with it, cross-site scripting, there's so many edge cases. There's so many edge cases with SQL injection. You don't want to try to sanitize the data yourself. So what you would rather do is use something like a prepared statement or some other type of sanitization function that will essentially ensure that whatever you're passing to your server side application can be trusted. And that was pretty much our 2 cents on that. Let me stop my share. Are there any questions? I don't think we got any questions in this. Either people were asking them and I can't see them, or we didn't get any. So we are on, I'm on Twitter. We're both on LinkedIn. If you want to look us up, ML Gualtieri is where I'm at. If you want to find us and send a comment to Gatsby, if you have other questions. This video is going to be online soon. I think even tomorrow it's going to be online, so you can refer to it later. We're also going to take all the content that we have in here, even the stuff we didn't get to. It's going to be presented as a series of blog posts on gatsbyjs.com, where we're going to do a deep dive into security, secure code patterns, what to look out for vulnerabilities. And that is that. How do you feel, Rodney?
Feeling pretty good about the workshop. I don't know about our friendship. There's a lot of, I feel like you taught people how to hack all of my information. And so now I need a moment to process all this. But goals are still trash.
There were no Rodneys harmed in the making of this video. Everything was done, nothing was stolen. It was all a ruse. But we did highlight what could actually happen out there in the real world.
Fair enough. But anyways, thank you. This was fun. And yeah, hopefully people learn stuff in the process.
All right.
Rodneys were only emotionally harmed in the making of this.
All right, all. It was a pleasure. Enjoy the rest of Gatsby Conf. We will check you later.